Thanks for clicking the video, guys. I appreciate it. Let's get through this. I don't want to keep you too long. I want you thinking more and listening to me less. So, and I apologize if I'm not 100% right now. I'm feeling a little under the weather, so bear with me. So 1 through 4 is obviously about the midpoint, and all I'm asking you to do is to make one statement. And so we'll talk about that in a second. First of all, let's talk about what is the midpoint, right? So remember, the midpoint is the exact halfway point of a segment. Okay, the midpoint is the exact halfway point of a segment. So let's suppose, let me draw it a little bit better. Suppose that I have a segment. I'll call that AB. Right, and let's suppose that the length of AB, let's suppose that that's 10 feet, inches, it doesn't matter. Well, the midpoint of AB is going to be the exact halfway point. So we'll call that midpoint M. Right, and what we know about AM now is that is equal to MB, right? So I hope I'm not giving too much away when I do this. In fact, that is also true. The segments are congruent and the lengths are also congruent, right? Such that these are both going to be 5 and 5, because 5 plus 5 is 10. Okay? Not too bad, right? So again, as geometry students, anybody can copy down the stuff that I write, but you guys should have the unique ability to take the words I say and synthesize it and think, how am I going to use this in the context of triangle congruence, right? So what can we say when we're given a midpoint? What can we say? We could kind of say, we certainly know that two segments are going to be congruent, and maybe those segments will be sides, right? Right, so it's actually a really great thing when you see midpoint, right? When you see midpoint, you really should instantly be saying, well, that's a third of the problem done, right? If I wanted to do side angle side and you see midpoint, you're like, oh, well, I got my first side knocked out. That's easy, right? Okay, so nothing too crazy. Let's keep moving. I want to keep you here all day. Oops, sorry. The reflexive property. The reflexive property for 5, 6, 7, and 8. Reflexive property, it's a property of equality. It's a property of equality and congruence. And congruence. So, and it's pretty it's pretty self-evident. I forget if it's actually an axiom. I'm pretty sure it is. I'm pretty sure it's axiomatic, but I could be wrong. Anyways, that's not relevant right now. What is relevant is, well, what does it mean? What does it allow us to say, the reflexive property? Well, it allows us to say that 5 is equal to 5, right? Anything is congruent to itself. Anything is equal or congruent, depending on what's more relevant, right? To itself. Right? Not too bad. So if you, let me just draw like a really bad triangle. We'll call it XYZ. Well, XYZ is congruent to itself, to XYZ. That's all the reflexive property allows us to say. But again, how can we use this in the context of triangle congruence? Well, it allows us to say that typically, in fact, I want you to think at these look at these exercises and think, what do they all sort of have in common, right? What is the thread that links all these together? The reflexive property. Sorry, I can't speak very well right now. I apologize. I'm really tired. The reflexive property allows us to say, basically, is a segment is congruent to itself, right? Right. So if I go back, well, looking at this triangle, I would say, well, YZ, segment YZ is congruent to segment YZ. Right? Not too bad. A little odd, but not horrible. So moving on to 9 and 10, it says write a congruent statement using the given information, okay? And I give you a little example. This is not an answer, okay? This is an example. This is what your answer might look like. This is actually what we would call the definition of congruence. Sorry, I don't know why I didn't put that on here. This is the definition of congruence, okay? So, given the measurements of two segments, how would you know whether they are congruent or not? Well, it's exactly what I give you in 9 and 10 as well. When given the measurements, I'll give you a hint. This little phrase should be part of your answer. Are equal should be part of your answer, okay? 11 and 12. 11 and 12 are actually pretty self-explanatory. It's pretty much review. Sorry, I don't know what that A is doing down there at the bottom. I'll get rid of that before I print this. Find the measure of angle BCA. So when I'm trying to find that, you guys should all know by now I'm trying to find this angle. There's a few ways to find it. And ACD is actually very simple. This is very much review. Okay? And then you answer this question, of course. How do we know if two angles are supplementary? That's actually a little bit harder to answer. And then this is just an exercise for a proof. So this is by far the hardest thing on the worksheet, but I feel like you have a lot of tools to help you out here. Okay, so everything that we've talked about is going to be a factor. It's going to be a reason. So at some point, remember, you always start out with the given, and I'm giving you a hint there, so that'll be your last justification. But maybe you're going to be using midpoint. Maybe you're going to be using something else, which is something you have to know as a geometry student. This is not easy. Maybe you'll be using, like, I don't know, one of the things that we've talked about on this worksheet, right? So everything on this worksheet is something that you could use to prove that ABC is congruent to triangle AEC. Okay? So I'll be available. I'm on Teams. I'm just not feeling well at all. So it'd be kind of irresponsible of me to show up to work. But yeah, if you have an issue, shoot me a message. Hopefully I can get back to you in time. But thanks for watching. I appreciate it.